Hello lovely students, in today's video we are going to start with binary trees. So what are binary trees? Before I start binary trees, it's important for you to know what rooted trees are. Now basically a rooted tree is a tree in which there is a distinguished vertex which is called as a root, and this vertex is distinguished from rest of the vertices. So such a tree is known as a rooted tree, right? Now in general, when we use the term tree, that means a tree which is not a rooted tree, right? If it is a rooted tree, I will specifically call it a rooted tree, and if it is not a rooted tree, I will call it a tree. But to give more emphasis, sometimes we use the term free tree to state or to tell that it is not a rooted tree. So this is a rooted tree, that means a tree with a distinguished vertex which serves as a root or which is called the root, and it is different from rest all the vertices. Now binary tree is one such class of rooted tree in which there is exactly one vertex of degree 2, right? Please listen carefully, this thing is very important. There is exactly one and only one vertex of degree 2 in a binary tree. Rest all the vertices would be either of degree 1 or of degree 3. Now, as I told you, to serve as a root or to be a root, that particular vertex must be different from rest of the vertices. As in case of a binary tree, I told that there is exactly one vertex of degree 2. So that means that particular vertex is distinguished or different from rest of the vertices. So that particular vertex of degree 2 serves as the root in case of a binary tree. So in case of any binary tree, the vertex which has degree 2 is called the root. Now, there are some important properties of binary trees which we all must know. The first property is that the total number of vertices, which I denote here by n, is always odd, right? So there will always be odd vertices in a binary tree. You pick up any binary tree and find out for yourself. You will see that n here, that means the total number of vertices here would always be odd. Like if I take the example of this particular binary tree, here the total number of vertices are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the total number of vertices here are 13, which is an odd number. First point. Now the second point is that if P is equal to the pendant vertices. Now we all know what are pendant vertices. Those vertices which have degree 1 are known as pendant vertices. So if P is equal to the pendant vertices and n is equal to the total number of vertices, right? In that case, the vertices with degree 3 would be n minus p minus 1. You can always check, take any example of binary trees that you have in your book and check for yourself that if n is the total number of vertices, p is the number of pendant vertices, then the number of vertices with degree 3 would always be n minus p minus 1. Now let us take a live example here itself. Here this is a binary tree with 13 vertices. So that means I can say that n here is 13. Then how many pendant vertices are here? Pendant vertices are those vertices which have degree 1. So this particular vertex has degree 1, this vertex has degree 1, this vertex has degree 1, these two vertices have degree 1, these two vertices have degree 1. So in total, how many vertices of degree 1 or how many pendant vertices? 1, 2, 3, 4, 5, 6, 7. That means in total I have 7 pendant vertices. So that means my n here is 13 and my p here is 7. So if I want to know how many vertices of degree 3 would be in this binary tree, I can calculate it using n minus p minus 1. So n here is 13, p here is 7, minus 1 gives you a total of 5 vertices of degree 3. Now you can count it for yourself. Vertices with degree 3, How many of them are here? This particular vertex is of degree 3. This vertex 1, 2, 3. 3 edges incident on this particular vertex, so it is of degree 3. If I call it vertex A. Then this particular vertex, if I call it vertex B, is again of degree 3. 1, 2, 3. 3 edges incident on B. Again, this particular vertex, if I call it C, is of degree 3 again. 1, 2, 3. 3 edges incident on vertex C, hence it is of degree 3. Now if I call this particular vertex as vertex D, again it has 3 edges incident on it. 1, 2, 3. So D also has a degree 3. If I call this particular vertex as vertex E, it again has 3 vertices incident on, edges incident on it. 1, 2 and 3. So the degree of E is also 3 here. So in total, how many vertices of degree 3? A, B, C, D, E. That means 1, 2, 3, 4, 5. Right? So what does my calculation say? Exactly 5. So this implies for all the binary trees that if the total number of vertices in the binary tree is n and the total number of pendant vertices is p, then the total number of vertices with degree 3 would be equal to n minus p minus 1. Now what is the level of a vertex? Here I have written 4 different levels. It starts from level 0 and ends at level 4. So these are the 4. So that means I can say that this particular binary tree is a 4-level binary tree. Now how do you decide the level of a vertex? The level of a vertex is the distance from the root to that particular vertex. Or in other words, the number of edges between that particular vertex and the root vertex, right? So if I have to find out the level of vertex A, how many edges are between the root vertex and the vertex A? Exactly 1 edge. So that means it is a level 1 vertex. Then if I have to check the level of vertex C, how many edges are there between the root and vertex C? 1, 2, exactly 2. So that means vertex C is at level 2. Then if I have to check the level of vertex E, how many edges are between the vertex E and the root? 1, 2, 3. That means vertex E is exactly at level 3. And if I have to check the level of this particular, the last vertex, I can call it vertex F. So if I have to find out at which level vertex F is, or what is the level of vertex F, so I will see how many edges are between the root vertex and vertex F. So that means 1, 2, 3, 4. There are 4 edges between the root and the vertex F. So the vertex F is at level 4. So this is how you determine the level of vertices. And what is the level of a tree? The maximum number of levels that you have in a tree is the level of a tree. Like here you start from 0 and go up to level 4. So that means this is a 4-level binary tree.